Okay, so this is a differential equation. So we know dy over dx in terms of x and y. And the question asks us to find y. So the only way to go from a differential equation to y is to somehow integrate. Now, we can't integrate unless we separate the variables. That means we want the y's on the same side as the dy. We want the x on the same side as the dx. And we want the dx in the numerator, not the denominator. So we can separate the variables. So this first step is called separation of variables. So we want to get the dx in the numerator and on the right-hand side. And we want to get the x again on the right-hand side. And we want to do the opposite with the y. We want the y on the left-hand side and probably in the denominator. So we'll end up with something that looks like this. dy over y squared minus y equals dx over secant x. Secant x is 1 over cosine x. So when you have 1 over secant x, that just means cosine x. So we can write that as cosine x dx. Okay, so that is just something that we know. And that, I guess, we can now integrate. So if you put an integration sign on both sides, we can integrate that, no problem. How do we integrate that? There's no point taking substitution because the derivative of y squared minus y is 2y minus 1. That doesn't exist here. But if we factorize the denominator, we can probably take partial fractions. So if we write that as dy over y times y minus 1, so I factorized this into two factors. And let's make some space. So, okay, so I can, in a different color, I can write this as two fractions, a over y and b over y minus 1. So now we'll do a quick partial fraction solution. A times y minus 1 plus by equals 1. So this multiplied by this plus this multiplied by this equals 1. So if y equals 0, a equals minus 1, and if y equals 1, b equals 1. So now we can rewrite this as, so this now gets rewritten as the integral of minus 1 over y plus 1 over y minus 1 dy equals the integral of cosine x dx. Now we know how to integrate all of that. It's ready for integration. So that we can integrate, that we can integrate, that we can integrate. So that's minus natural log y plus natural log y minus 1 sine x plus constant. So that's your general solution. And the question tells us that when x is 0, y is 4. So we can substitute x is 0, y is 4. So that will give me minus log 4 plus log 3 equals c, because sine 0 is 0. So c is equal to log 3 over 4, because when you subtract logs, you divide. Okay, so now we know the constant. This constant goes there, and our particular solution now looks like this. Log y minus 1 over y equals sine x plus log 3 over 4. The question is asking for y, so we need somehow to get rid of the logs. So remember, there's a little e there, so e to the power all of this should equal to that. So remember the definition of log. If you have log of a equals b, then it means e to the power b equals a. So e to the power b equals a. So in this case, we've got e to the power sine x plus log 3 over 4 equals y minus 1 over y. When you have a sum in the power, you can write it as a product. So it's e sine x times e to the ln 3/4. And you can split this fraction. You can make it y over y minus 1 over y. So that's y over y minus 1 over y. And that, of course, is just 1. Now, e to the power log 3 over 4 is just 3 over 4, because the e is the opposite operation to the log. So y over y is just 1, and these cancel each other, so you end up with 3 over 4 e to the power sine x. Now you just need to rearrange. So I guess we could bring this to that side and that to that side. So you have 1 over y equals 1 minus 3/4 sine x. If you want to get rid of the 4, you just multiply both sides by 4. So you'll end up with 4 over y equals 4 minus 3. I keep writing sine x. I mean e to the power sine x. And then if you invert that, and you invert that, you have y over 4 equals 1 over 4 minus 3 e to the power sine x. Then if you multiply both sides by 4, you end up with that, which is the expression they were looking for. So that is your final answer. So the main thing is you start off with separation of variables. Then before you integrate, get rid of the secant, replace it with a cosine, factorize the denominator, partial fractions. That'll give you your general solution. You substitute your initial values. That'll give you the value of the constant. A little bit of manipulation, and you should be able to arrange the equation into the form they asked for. So I hope you found that helpful.